Hello and welcome to another Code Remix Weekly. We are your temporary hosts in Sam and Tim's absence because they're out. Sam's out at the DPA Gradle Summit this week, and Tim's out this week and next week. So we are your temporary hosts. I'm Kevin Carpenter. I run our platform engineering team here at Moderne.
I'm Lindsay. I'm head of design at Moderne.
All right, we'll just go ahead and hop in. We'll do our normal talk about the announcements that we have for the community and the Moderne for this week. So let me go ahead and get that shared. All right. So the very first announcement we've got Open Rewrite 8.36 available. So we now run on Java 23. We fail fast on Maven POM.xml issues. And maybe one of the most exciting things that we have is we now have an upgrade to Android. So we have Android support for both Open Rewrite and the Moderne CLI, and a recipe to update your version of the Android SDK as well. Some new Spring changes to migrate HTTP status to status code, new Makito recipes. And then if you are interested in a full list of changes, just go visit and we'll include these links as well, but go visit Rewrite Recipe Bomb version 2.20, and this will tell you all of the versions of all of the rewrite jars and recipe jars. So Moderne has also been named an IDC innovator, leading the charge on automated remediation. Katie Norton and the IDC team have been at the forefront of identifying an industry shift toward auto remediation. It's no longer enough to just find problems for developers to fix, something we've been saying for a long time. This is a priority for Moderne as we help enterprise companies automate code security, migration, and quality at scale. Which brings me to our next point. We have a new customer use case study with Interactions LLC. So they replaced Veracode with Moderne for vulnerability remediation and a whole bunch more. So go check that out. That's on our blog. We've also got some upcoming events that you might want to go check out. So Justine, our AI research engineer, is giving a talk at the Montreal Java User Group on September 26th. I believe it's in French, I would guess. But she's giving a talk on just automated code remediation with Open Rewrite. Our own Tim Tabake is giving a talk on transforming code with Open Rewrite and Refaster with Rick Ossendriver at Devox Belgium. I believe that's on Monday, October 7th. So if you're going to be at Devox, go check that out. And then Tim is presenting at the Nord Jug on October 15th. So we'll provide links to all of that. And I think that's all the announcements we have today. For today. So let's go ahead and get into the meat of today's discussion. So how's it going, Lindsay? Are you ready for this?
Yeah, I'm really excited. I was just telling Kevin before we got on how cool it is to go back and revisit the original designs and like how far we've come, how much engineering effort that has gone into building out this new user experience. And yeah, really excited to show off what we started with and where we are now, how we got there.
Awesome. So I'll just talk really briefly about how we use recipes as building blocks. So what we're going to be talking about today is what we call the recipe builder, which is a way to turn these building block recipes into a bigger recipe. So there's two types of recipes. Imperative, which is where you write the code to visit the LST and make the changes or search for the elements that you're searching for are going to change. And then declarative, where you take other imperative recipes or other declarative recipes and build them together to create a more cohesive experience, such as a migration, or we'll see a few more examples of declarative recipes here in a bit. So in the Moderne SaaS platform, we have this builder, which lets you add a set of recipes and then run that set of recipes. So for example, if I want to run, let's say, we'll just start with common static analysis. So this is a set of 65 recipes that fix common source code scanning issues We started with just sonar cube issues, but we've expanded out from there now. So these are things that will fix very commonly found issues in your code. So if I want to run these individually, I can, but what we've done here is compile them together into one cohesive declarative recipe. So I can add this recipe to the builder, and that's going to add just a single recipe here. And you can see the YAML representation over here. If you've interacted with the IntelliJ Ultimate Edition, the newer version of the IntelliJ Ultimate Edition, they give you some tools to build open rewrite recipes in the IDE. And this is the representation you might be familiar with. But you can see this is a recipe comprised of 65 other recipes, and all you see is the top level recipe here. Okay, so let's go ahead and get rid of that and go back and let's add the individual building blocks. Because let's say I don't agree with one of these building blocks. I don't want it to be run as one of my best practices. So let's add those to the builder. And now we've got all of them in here. And so I don't want the fix, what is it called? Fix braces or fix missing braces. So if I search for it, I can find it down here, need braces. But in order to actually remove it, I have to scroll in this list to find it. And then I have to remove it there. Yeah. And I'm not even finding it. So I'll just remove a random one here. And then I have another option. I could copy this, edit the YAML. There were a couple other problems with this builder. One is, so this is stored locally in your browser, and there's only one, like you can only have one. So if you want to change this, you would generally copy or download this and store it off somewhere, maybe a Git repository, or maybe just locally in a file, and then clear this out and start over. Yeah. So not super extensible in that way. It's also, as you saw, really hard to discover what's inside a recipe. So like, if we go look at the Spring Boot 3 recipe, you'll be able to see, for instance, let's see, Spring Boot 3 best practices, yeah. And so if I add these, so there's 7 recipes here, but that hides a lot of complexity because each of these, so like Spring Boot 3.3 chains to Spring Boot 3.2, which chains to Spring Boot 3.1, and so on. And so if we go back to the 3.x, even if I add these selected to the builder, you only get one level. You only can view essentially one level of these recipes. So that's where the builder v2 comes in. We were trying to solve those problems. Just the one recipe at a time. Adding a new recipe requires you to go back to the marketplace, so lose the context of the building blocks you've already added, and it's hard to discover what's inside of a recipe. So that brings us to the builder v2. So I'm just going to demo by starting from a new recipe here. I just want to call out before I get started on all this. Unfortunately, couldn't be here with us today, but Kyle on the platform team did pretty much all of the development of this, and we're very, very happy with all the effort that Kyle put into this. And you'll see toward the very end, all of the like technological stuff that went into it is pretty complicated, and so I hope you look forward to this. All right, so let's create a new recipe, and this is going to be I'm going to call this Kevin's common static analysis. And also just do CSA for common static analysis, and then CSA without braces for my description. And so that creates essentially a blank recipe. So we just have the top level node here, and that's the description of the recipe itself. I can make changes to it here in the middle, or I can make changes to it over here on the right. So if I click here, I'm going to add, I can edit the recipe details, all those things I just set. I can also add a recipe to this recipe node. So let's add that common static analysis recipe. I can click it here, but in the interest of, because this was a recipe that I was viewing recently, I can also come over to this recent recipes and come down here and view it. So if I click common static analysis issues here, select recipe. Okay, now you can see that all 65 recipes from common static analysis issues are present here. And we have a topology view that shows what the structure of this recipe looks like. So this one's flat, just all of those are immediately off of the parent node. And I will, so there's a few actions we can take here. We can zoom in so that we essentially fit the entire recipe into the view. We can zoom in on just this node. Let's pick a different one here. Zoom in on just this node. I can hide this box so you can see the whole topology. And then we can look at the legend here, which shows that this, let's go back to the top node, that this purple color here, bluish purple color, is a recipe node. Pink are preconditions, which we don't have yet. I'll talk about that in a bit. If I wanted to search for that braces recipe, so fix missing braces, that now turns this greenish shade. And then it also tells you what the controls are. So you can left click to rotate the view. You can right click to pan all directions, and then you can scroll in and out, and it scrolls to and from your cursor. So one of the things we wanted to do is I wanted to remove this fix missing braces because this is something that, let's say, I don't agree with for my standards. So I'm going to now bring back that window, fix missing braces, and delete the recipe node. It gives me a confirmation box. I think you probably saw when I was on the old builder, we didn't even get a confirmation box on there. So now this common static analysis, you notice all of these have the rewrite logo because these are open rewrite recipes, and they are out of the box recipes, meaning they haven't been changed in any way for usage here. This icon here means that we're in a custom recipe. So now this common static analysis issues recipe has become a custom recipe because we've removed one. We can also come up here to the top level and we can add a new one. So I'll do that from the tree over here. And so let's say I also want to, let's see, I want to replace my system.out logging with a logger. And so I'll select that. And then, yeah, don't want to add a logger. Logger name log is the default, and SLF for J. And then default level is info. So let's update that. And so now, in addition to having all of these recipes, I also have the use logger instead of system print statements and its recipe list here. And so now I can take this and I can download this YAML and paste this into my Git repository or whatever, or I can just leave it here in the browser. So let me just go ahead and create a new recipe, because now we are not limited to a single recipe. And so this is I'm going to use Spring Boot 3 here. So let's do Kevin's Spring Boot 3, SB3, but with DGS framework. So Moderne recently upgraded all of our libraries and microservice to Spring Boot 3 in this past year. And one of the things we had to do as part of that was also upgrade the DGS framework, which we use for our GraphQL API. And so I'm going to bring in the Spring Boot 3 recipe here. I believe, yeah, it should show up here because I was viewing it recently. Select recipe. And now you get to see the real power of this. So a little bit bigger, we have 2,619 recipes within the Spring Boot 3.x best practices recipe. So I can zoom in. Let me just pick one of these. So change. This is I wanted to click on the root node here. Yeah. So we'll click on this one here. And you can see as I select individual pieces of this, it will highlight just those nodes. So you can limit the scope of what you're working on to just a subset of the recipe. And this shows you the topology of the entire recipe. So you know effectively, if I remove this migrate to Spring Boot 3.0, I'm removing, essentially half of this recipe. And similarly, like we have the entire Java 21 migration as part of the Spring Boot 3.x best practices. So half of this recipe is migrating to Java 21. Well, a little less than half, and a little more than half is the entire migration to Spring Boot 3.3.
Yeah, it's pretty incredible to see like this migration, all of the steps, those building blocks to make that migration run. Previously, all that stuff is just hidden, and we can talk about how many hours we're saving, but to see it in this topology, like that scope and the breadth, that really is like what we're trying to achieve with this view. And some people might like see this and think it's like pretty something they haven't seen before, and that is truly intentional because we want to show just how much effort and how many parts that are constituting these recipes and these migrations.
Absolutely. I was pretty floored the first time I saw this. I think we'll show a little bit later the process of getting here as well. So like if I just wanted to look at the upgrade dependency, just the dependency upgrades alone, I can filter this view to just those. And there's a lot of them, so it'll take a second. Yeah. So we have, actually, it's upgrade Gradle or Maven. So here we go. So you can see all of the Gradle and Maven upgrades are highlighted in this green color, if you can see that. And you can see that over here as lighter than the rest. And there's just a lot of, like we have, it says 167 results here across the entire recipe. So that's a big chunk of what the Spring Boot 3 upgrade ends up being. And I want to talk about, I want to go back a second. So now I can show you that you can save this off. It's automatically saved in the browser as well. And then you can also open previous ones that you've modified. So if I wanted to go back to the common static analysis, I can do that. And then let's say that yes, we'll go back to common static analysis. And let's say that I only want to run this common static analysis on recipes that have, that are Java files. So now that we have C# support, you can run common static analysis on C# code as well. But let's say I only care about running it on Java code. So let's do find source files. Find files, yep. And I want to add that as a precondition. So a precondition essentially says, run this recipe first and throw away its results. If it would have had any results, then run the rest of the recipes. And if it wouldn't have, then skip the rest of the recipes. So yeah, I want to do ****star.java. So that says anything that ends in .java at any point in the hierarchy. So we'll update that. And now you can see, I'll hide this this box again. You can see we've got this precondition here matching this pink color for precondition node. And now if I run this, it will only find Java code. I could also do this and just do, .cs, so it would only run on my C# code as well. And then if I want to export this, I can download it, I can copy to clipboard. I can also, the interesting thing here, so let's do copy to clipboard, and then I'll do import from YAML. I'll paste that in, and just for fun, I'll just name this CSA2 so that it won't overwrite the existing one that I have. And then I'll import. And so this will then be added to the list of recipes that I have available. So now if I go to manage recipes, we'll have that CSA2 there as well. Let's see. Oh yeah, so the topology view is really cool for seeing how deep something is. But in a lot of cases, the changes you're making, you're doing from the tree view so that you can see what recipe you're making changes to. And so there's also an option to move the topology view to the sidebar over here, and then you can operate on the recipes over here in the middle. So I can go and remove these here. I can let's find one that has options. Yeah, here's one that has options. I can edit those, apply recipe to test sort, set true. And now that I've done that, well, this is already a custom recipe. But if I had done that and this wasn't a custom recipe, it would have made it a custom recipe. And then we did. I'll talk about the camera controls a bit later on when we talk about the technology. I want to hand it over to Lindsay so we can talk about so she can talk about the design journey and how we got to this point. So I'll stop sharing if you want to take over.
I'm going to share my Figma file, which is definitely, I'm really zoomed out at the moment, but I'll just kind of set the context for what we're looking at. So starting on a new feature like this is pretty daunting. As a designer, coming to the team at Moderne, I was really excited to work on like new, innovative things that would be challenging, and this has definitely been a huge challenge. So looking at that spring boot recipe, we wanted to think about, like Kevin said earlier, how do we explode this out and see the full scope and breadth of what this recipe is composed of? So in Figma, I decided to really lay that fully out in this infinite canvas, showing all of the recipe building blocks that make up this migration, and just showing the full view. What does this look like as an experiment? And it is too big. I can barely show this in a demo. But
I felt so bad for you when you started going through this. I was like, yeah, I think it's important for us to see this, but man, I feel bad for you.
I know I was very nervous in stand up, kind of showing the team my progress and like, are they really going to wonder what we're up to? And definitely they, were encouraging. We like kept going and looking at other products. So I looked at this tool called Autorize. This is like a networking tool, trying to see like how they're using cards and things connecting. Like we want to show the dependencies, how they're connected together within our recipes. What might that look like? But I mean, this is an epic fail. But the only thing we wasted was a little bit of time. So we kept going and kept experimenting and trying different graph models. You'll see here, this is the same spring recipe, a different kind of model, different ways of relational graphs to expose like how things are connected. And if we can make some sort of map that users can navigate through and reason about recipe editing, creation, and just navigating to understand, what is within these recipes. So very challenging. We like ran over a little bit of roadblocks, looked at some like CAD software to see like, can we learn anything from these platforms, how they help mechanical engineers understand those systems, how they offer those their architectural drawings, and what might we learn from them and apply to our this new view.
And if I remember correctly, that's because we were thinking of, correct me if I'm wrong, we were thinking of these recipes as components. And so CAD software became the next logical, like, oh, we can pull inspiration from there.
Yeah, like everything. Like what we trying to like think outside of like technology platforms, like what do other what can we learn from what other people have done with similar problems of like showing dependency networking. And we came onto this idea, I think it was like Jonathan who brought forward this idea of having this forced layout diagram. So we had seen this in some data visualization platforms being used, people using it for experiments. And Kyle and I kind of took that idea, examined it, saw if we could do a really small proof of concept with what we are already using today, and just implement it. Do the smallest version possible to see if this is like a path that we want to pursue. We did a little bit of sketching, but when we went into code, and you'll see this experiment was living within the recipe details page. So we could start to look through the whole catalog of recipes and see how they're rendering out. So we got some like interesting graphs, like maybe not entirely useful,
I
but
believe the spring recipe looked like the Millennium Falcon in this view, if I remember correctly.
yes, yeah, like super fun experiments. But like, okay, how do we make this uh, an interface? Like, how do we take this like cool image and start to make it a little bit more useful? So again, I went out into the internet, looked at some examples, and started to see some examples that like we could borrow some elements from, and start building something that would make sense. So this probably is the closest to what we have today. So this is like a very flat rendering. But at this point, we had decided to introduce the tree. So this list side by side with the diagram topology, and this notion of like what happens in the topology happens in the list. How do we manipulate the view so that we can zoom in and zoom out, see like 2,000 nodes, and also view one node and be able to do that with a seamless, smooth user experience. So you kind of
You
see,
can see it really starting to take shape there.
yeah, so these are like very crude sketches. I'm kind of showing you, the good, the bad, the ugly. But like lots of experimentation is starting to happen here. And then at this point, we started to really hone in on, okay, um, this 3D rendering. This was kind of like another leap forward in our design. And at this point, we started having just fun looking at what different color combinations. Kyle created this like really cool color debugger. You'll kind of see, oops, on the left here. So I could experiment with colors and see like what makes sense, what different combinations we could try out. And then at this point, the topology was read only. So no editing is happening. We're grappling with like getting the 3D topology to render with the list, because there's like quite a bit of load happening there. And Kevin will talk about that. But kind of the last step that we went through was this idea of editing. So adding this speed dial. So it took this cue from material design to like be able to add it edit a node using this component. And then later on, we have the editing also added to the list. And we kind of took that idea from Figma. Figma allows if you can see my mouse, this like locking and showing and hiding. There's like a whole menu that appears out of this list. So yeah, trying to further iterate on the view as we go. But I will pass it over to Kevin, and you can kind of talk through the technology. So when we went from that flat topology to 3D, that was like not trivial. There was a lot of work to make that happen. And yeah, I'll let you tell that story.
Nice. Yeah. Just another, well, as I get shared here, just another real quick shout out to Kyle, because what I'm about to talk to you was all Kyle. So I'm gonna go back to this view, and I'm gonna go back to the Spring Boot 3 recipe as well, because it really demonstrates this the best. So I think I can. Oh, you can make it bigger, but you can't make it smaller. Okay, fair enough. So there were really three problems that we had to solve technologically here. Once we knew what we wanted to accomplish, there were really three, and how to we knew we wanted it to be in 3D. We had three problems to solve. The first one is the nesting of the data. So as you saw before, the old builder only had one level of data. And if I go to this recipe, so I'm going to go to this recipe's details. On pretty much every page on our website, you can see this API examples link, and that will take you to, so I want to get the recipe details to be able to get that recipe list, and it will demonstrate the GraphQL request that you have to make to get the data that's displayed on the page. And so you can see here, so there's a recipe list, and each recipe then has its own recipe details, which has its own recipe list, and so on. And so that technically could be nested infinitely. And so we had to figure out how we were going to construct the tree view from this without having to do like, okay, get the next level, get the next level, get the next level, because we had to collect it all up front. And so if I run this now, you can see we'll do get recipe list here. So that this brings us to the Spring Boot 2 best practices, which then brings us to, we've got a recipe list here that has a set of Spring Boot 2 best practices. And then try to find, Java 21 then has its own set of recipes, so upgrade to Java 17 and so on. And so the first thing that we had to do was turn that, grab that data and turn it into a set of nodes, basically flatten it into a set of nodes and then links between those nodes. So you get the set of nodes, find the nodes that have no parents, and that becomes your root node, and then the nodes that only have those as parents, and so on. And then that's how you get the list of things that we have to turn into nodes in 3D space. And then another thing that we had to solve as part of that is the order of these matters. So if I click on this and drag it, I can move it in between these. I can put it in between these nodes, or I can move it on top of one of these nodes. If I put it in between, it's just going to change the order. But I can also drag it in. So this replace string literals with media type into this replace string literals with HTTP headers constants. And then that creates, it'll take a second. Yeah, there we go. That creates a custom recipe that contains both of those. And that's super useful if you want a precondition on, you just want to run these two recipes in a specific case. So you'd add like a find files precondition or an is in repository precondition that would only run these two in certain cases. And this drag and drop was really hard, and we had to wait for a new version of this, we had to upgrade to a new version of this tree in Material UI. So the next problem that we had to solve was where to put the nodes, basically. So we had to calculate positional data for all of these nodes. It had to be quick, and it had to be consistent. So every time you come to the Spring Boot 3 recipe, it had to always display the exact same layout. There couldn't be any randomness. It couldn't be moving around. You'll notice these are all static. I can move around them, but they don't move. So if I add a new node, it will always put it at the same place, things like that. And so Lindsay talked about a force layout, and that's what we ended up going with for this. So a force layout essentially means give each node a weight and then apply force to them to have them explode into where they're supposed to be. So you generally do this by putting all of the nodes at the exact same location and then running a simulation that explodes them out. And then once it's stable, or after a certain number of iterations, you get a set of ending positions, and that's what you use to render it in 3D. But what we looked at we looked at a couple ways of a couple libraries for this. We looked at D3 first, but it wasn't as modular as we wanted, and you had to code the algorithms yourself for the force diagram. So we ended up going with a library called ngraph. Ngraph is very modular. There's a force layout a force layout module for it that does the explosion for you, the simulation that moves it into where it needs to be. And what we found out was, after putting all the nodes at the same place and then applying force to them, exploding it out, nodes that had similar weight ended up positioned similarly, and it was hard to distinguish between them and where they were supposed to be. So we added in another module called HDE, or high density embedding, that lets us run a simulation in 2D first, or a set of simulations in 2D, similar to, if you think about race cars in a NASCAR race, they start at different positions, which potentially affects the outcome, but doesn't decide the outcome. It doesn't decide where they end up. So we run a set of simulations in 2D before then putting it in 3D space and then running that force layout simulation. And so what you see here is the result of that. And then if I'm going to go ahead and remove this just so you can see how quick this runs. So all of this happens before you see a single node pop up on the view here. So 1, 2, 3, 4. So about 4 seconds to do all of those simulations behind the scenes. I'm consistently impressed with how quickly that renders. And so that's how we decide where the nodes are going to be. And then the last thing we had to decide was how do we actually render it? And so what we ended up going with there was Three.js. So that's used to create 3D graphics using WebGL in the browser, and then 2 modules for Three.js to actually let us use this within React without having an insane number of render iterations. So that sort of gives an overview. I forgot to talk about the camera controls, which I think is one of the most interesting things. So Three.js gives you the ability to do this rotate and this pan out of the box, and it also gives you the ability to zoom in and out. But when you zoom in and out, it zooms in the middle, and also it also is just literally a zoom, and so it distorts. So for instance, if you imagine that I'm going to hide that box. So if you imagine that right here in the middle is where we're zooming to, it would very heavily distort these nodes up here where they would look essentially elongated. So instead of zooming, we actually coded our own camera controls, and we put the camera on a dolly and then move it toward the cursor. So if I'm going to mouse my cursor here over Migrate Spring Boot Properties to 2.0, and as I zoom in, you can see the camera's going in toward that node. And then it goes back out. So we don't actually zoom. The zooming is moving the camera on a dolly. I recommend if you want to learn more about this, go check out the blog that we have on moderne.ai/blog, Building the Recipe Builder. So this was written by Lindsay and Kyle. Lindsay, who you know now, and Kyle, who was the one who did all of the engineering on this builder.
Yeah, more details in there if you want to review it.
Yeah. So I think that's it. Anything else? Any closing thoughts, Lindsay?
No, I'm glad we got to revisit how we did this, because it happened over a couple months, and then now we're on to some new features that we are building that we're excited about, and it's nice to take a look back and see how far we've come. And the builder. It's interesting because it wasn't really well received by our customers. It was very well received by the sales team. And now people love it. I think it's just when you see something so new and unfamiliar, it's like hard to adjust. And certainly users are used to the old way or the original way that they do something. So getting them to learn a new way is always challenging, but I think we're ready to get rid of Builder V1. So
yep, it's a good time to give this presentation for that. You reminded me, actually. So we've actually made a lot of improvements based on our customers' feedback.
Yeah.
So one of the pieces of feedback was that one customer specifically works on a very small subset of a recipe at a time. And he wanted a way to be able to work on a component of this at a time rather than the whole thing, and then put them together like building blocks later. So you can certainly do that through a recipe jar where you create your building blocks and then put those in a recipe jar and then upload those into the platform. But now with the recipe builder, I can also go in here and I can add recipe to this recipe node, click builder recipes, and then add in the common static analysis recipe that I was working on. And that's going to create a copy of it into this recipe. And then when I make changes to it, I can remove it out of here and then re-import it. So now not only is Spring Boot 3 here, but I also have my common static analysis recipe in here. So we made a lot of improvements based on customer feedback as well. And people seem to be generally happy with it now.
Yeah, but we're not done. I made issues this week around the builder for like improvements that we can make, and I love giving user interviews, so I'm going to give a plug for myself. If anybody would like to do a user interview with me, reach out to me on LinkedIn, and I'd love to do one-on-one, get some feedback. But yeah, certainly we do this all the time. We talk to our customers to get feedback and continuously improve. But yeah, still.
And the builder is also available on app.moderne.io. Anybody with a GitHub account can use it with the open rewrite recipes that are out of the box, and be able to run on open source repos or download it to use in the open rewrite plugins as well. If you're not yet a Moderne customer, also reach out if you would like to be, if you would like access to a platform for your private code as well. So, all right. Thanks so much, Lindsay.
Yeah, thank you.
Guess that's it. We'll see you next week.
Right.